In this video, we'll look at how to convert from polar coordinates back into the familiar rectangular coordinates. And to preface that, let's look at this point P on the Cartesian plane. Notice that we have our x and our y-axis, and if we think of this piece here as the initial side of the angle, theta, and we also then have the terminal side of that angle, we can label different parts of that. Notice that if we drop down a line from the point P, we have a familiar right triangle. And we're just going to label some parts. We have x, y, and the hypotenuse up to that point we'll call r. And now go back to the familiar trig functions that we're used to. Let's talk about sine theta. Remember that sine theta is just a ratio. It is the opposite over hypotenuse, or in this case, sine theta is opposite y over the hypotenuse r. So we have y divided by r. And we also have cosine. Cosine theta is adjacent over hypotenuse. And again, referring to the angle theta, the side adjacent would be x, the hypotenuse would be r. So we have x divided by r, which is essentially what we have here. Again, these are coming from this right triangle. And suppose we wanted to now solve for y and r so that we can convert from polar r and theta back into rectangular x's and y's. So if we have sine theta equals y divided by r, we can simply multiply by r on both sides, and we now have r sine theta is equal to, those r's will divide out, and equals y. So y is r sine theta. Similarly, if we had cosine theta equals x divided by r, and we wanted to find x, we would again multiply both sides by r, and we would get r cosine theta equals, here the r's again divide out, x. So we have a formula for x. X is r times cosine theta. We can use these rules to convert from polar into rectangular. In these examples, we want to convert from the given polar coordinates into their equivalent rectangular coordinate. It's helpful to plot this point, just a quick sketch off to the side. Let's plot that point. We'll start by looking at the angle pi fourths, and then from there 1, 2, 3, 4, 5 units away from the pole. So there's our point in polar. Now it should be the same point in rectangular form, we just need to find it. Recognize that that point is in quadrant 1. So the rectangular coordinate that we find better be in quadrant 1. Let's use the formula now that we had from earlier to find those coordinates. X is r cosine theta. R in this case is 5. And we have cosine theta, we are told, is pi fourths. We'll have to get some practice with the unit circle. Cosine of pi fourths, think about that unit circle. That is square root of 2 divided by 2. And when we simplify this, we get 5 square root 2 divided by 2. The formula for y is r sine theta. Now plugging in the given info, the r is 5. Sine theta, we are told, is pi fourths. Again, more practice with the unit circle. Sine of pi fourths is, again, root 2 over 2. Simplify and we get 5 square root 2 divided by 2. That means our coordinate, the x coordinate, is 5 square root 2 over 2. The y coordinate, 5 square root 2 divided by 2. This is now the rectangular coordinate. Recognize that that is indeed in quadrant 1, which matches what we said earlier. In example B, again, let's do a quick sketch off to the side. We have an angle of 5 pi 6. That is somewhere over here. But recognize that the r is negative, which means the point comes down into quadrant 4. So we'll make a note that this is in quadrant 4. That means our rectangular point had better be in Q4. Looking at our formulas, x is r cosine theta. R, we are told, is negative 2, and we're trying to find the cosine of the given angle, 5 pi 6. Cosine of 5 pi 6, again, unit circle practice there, that would be negative square root of 3 divided by 2. So that is root 3. And then formula for y is r sine theta. Plugging in the given info, r is negative 2, sine of the given angle, 5 pi 6. We have negative 2 times the sine of 5 pi 6 is 1/2, so that gives us negative 1, meaning our rectangular coordinate is square root of 3, negative 1. And recognize that this is indeed in quadrant 4. Our x value is positive, y value is negative. That's going to push us down into Q4. In our next example, we will again start by getting a quick sketch of that point. The angle is negative pi thirds, so that's going to be down here. But notice that r is also negative, which pushes it to the opposite side of the pole up here, which means our point is in quadrant 2. Our rectangular point should also be in quadrant 2. X is r cosine theta. We have negative 3 times the cosine of negative pi thirds. That is negative 3 times positive 1/2. So we get negative 3/2 as our x coordinate. Formula for y is r sine theta. R we are given as negative 3, and then we have sine of the given angle, negative pi thirds. Going to the unit circle, sine of negative pi thirds is, that is negative root 3 over 2. So that's negative 3 and negative root 3 over 2, meaning we have positive 3 square root of 3 over 2. The rectangular coordinate would then be x is negative 3/2, y is 3 root 3 divided by 2. So this is the rectangular coordinate. Recognize that that is in quadrant 2. X is negative, y is positive. That puts us in Q2. In example D, again, let's sketch the polar points. pi 6 is up here, but again, the r is negative, so that's going to push the point down into quadrant 3. Again, we'll make a note of that. Should be in quadrant 3. X is r cosine theta. We have negative 4 times the cosine of pi 6. That is negative 4 times root 3 divided by 2. When we simplify, we get negative 2 square root of 3. Y is our sine theta. Plugging in the given info, negative 4 sine of pi 6. Again, going to the unit circle, sine of pi 6 is 1/2. So we get negative 2. That means our rectangular coordinate is negative 2 square root 3, comma, negative 2. And if we think about where that is, negative in the x direction, negative in the y direction, that puts us in quadrant 3. In the next two examples, we want to use a calculator to make these approximations to get into rectangular coordinates. These are some funky r and theta values, so we can't use the unit circle. We'll use the calculator to get an approximate coordinate. X is still r cosine theta. So in this case, we have negative 3.1 cosine of 182 degrees. Recognize that that is in degrees. So when we go to the calculator, we want to first make sure our mode is in degrees. By default, mine was in radians, so I'm going to go down and change that to degrees. Then exit. And now we can type in negative 3.1 cosine of 182. And here we get roughly 3.1. Y is our sine theta. In this case, negative 3.1 times the sine of 182 degrees. We are already in degree mode, so we just need to type in negative 3.1 sine of 182. And here we get roughly 0.1. So our coordinate in rectangular form would be 3.1, comma, 0.1. In our next example, notice that the angle is given in radians. So we want to make sure we go back into the mode and change that back to radians. It's easy to overlook that and do the calculations with the wrong measurement, and we can get answers wrong if we're not careful. So x is r cosine theta. More specifically, for cosine of 3.6. For cosine, we're in radians, so we'll just type in 3.6. And this gives us roughly negative 3.6. To calculate y, we take r and multiply by sine theta. R in this case is 4. Theta is 3.6 radians. Back to the calculator. For sine, we're already in radians. We just need to type in 3.6. And here we get a y value of roughly negative 1.8. So our rectangular coordinate is approximately negative 3.6, comma, negative 1.8.